All right, hello everyone. Today we are doing this assignment right here, the bike ride assignment. All right, it's not too much, not too much. Got one side of the paper, the back side of the paper, and we're done. All right. So here's the situation: Jolene and Amadou rode their bikes from their school to the park. All right, so Jolene and Amadou are riding their bikes from their school to the park. The graph below represents a portion of their journey. All right, now take a look at that graph. Take a look at that graph. Just take it in. Maybe you want to pause me for a minute just to kind of figure out what's going on. Can you tell me what the x-axis is labeled as? Can you look at a graph like this and tell me, ooh, I know what the x-axis is and I see its label. Hopefully you were saying it's the seconds, time in seconds, right? This is the label of the x-axis. The x-axis is this horizontal one. What about the y-axis? What's the label of the y-axis? That should be pretty easy. Yeah, hopefully you're saying it's the distance from school, right? The y-axis is the vertical. The y-axis is this vertical line from 0 to 90 on this graph. The x-axis is from 0 to 28, the horizontal line on this graph. All right, so what we're seeing then, this graph is showing us a relationship of the distance from school compared to time, over time. Distance from school over time. So what is this line here, this solid line? Who is that? Is that Jolene or Amadou? Take a look. Well, hopefully you looked up in the upper right-hand corner here, and you're like, wait a minute. Solid line means Jolene. The dotted line is Amadou. All right. So Jolene started here. What was the distance from school? What was Jolene's distance from school right here? Hopefully you're saying, hey, it's 0. Her distance from she started at a distance from school of 0. What about Amadou? Can you tell me what Amadou's distance from school was when she first began? When they first began? When time is 0? What is Amadou's distance from school when time is 0? All right, well, there's his time in seconds, right? There's time in 0. So we need to go up to where Amadou's at. Amadou is 40. 40 what? 40 yards from school. All right. So Jolene starts at school. Her distance is 0. So if your distance from something is 0, that means you're there. Amadou starts 40 yards away from the school. And let's see. What does it mean? What does it mean right here that this line right here is steeper? It's steeper. It's a steeper slope than this line right here. What does that mean if Jolene's line right here is steeper than Amadou's line right here? What does slope mean in a graph? Remember, it's like a phrase, the rate of change. Hopefully you remember that, the rate of change. This steeper slope means there's a faster rate of change. In this case, it means she's moving faster, right? The steeper slope here means she's moving faster than Amadou is moving much slower. The line isn't as steep. Think of it like a sled on a snowy hill. The steeper the slope, the faster you're going, right? The steeper the slope, the faster the person is going. In this case, they're going away from the school. They're both moving away from the school. Their distances are going up. That's how we know they're getting further away from the school. But the fact that this line here is steeper than this line here means Jolene is moving faster than Amadou is for those first 6 seconds. How did I know this was a 6? How did I know this point here was a 6? It's between 4 and 8. And I see it starts at 0, goes to 4, goes to 8, goes to 12. So we're adding 4 for every other unit, which meant to me, what's the number between 4 and 8? That would be 6. 6 is the number between 4 and 8. So that even though that wasn't labeled, I just kind of as we look at these graphs. All right. Tell me, what is Jolene's distance from school at 12 seconds? Look for where Jolene's line meets the 12-second mark. All right, hopefully you're saying, wait a minute, time is down here. Time in seconds is down here, so 12 seconds. There's my 12, so I have to trace up. Where does the line connect? Oh, right here. Same thing as Amadou's. What distance from school that is? Well, distance is over here, right? Distance from school in yards, so we got to go from here. 50. 50 yards from school is Jolene's distance from school at 12 seconds. Can you see how that works? What is Amadou's distance from school at 24 seconds? You're looking for where time in seconds is 24. You're tracing that up to see where does Amadou's line connect. And right here's where time is 24. So you were tracing that up to connect. All right, Amadou at 24 seconds was 60 yards away. All right. Let me pause this recording. Hold on. I got someone coming on in. All right, sorry for that. Let's see. This is interesting right here. I noticed that Amadou, the line actually stops going up and starts to go down for a little bit. What does that mean? If the line changes direction, Amadou was getting further and further and further away from school. What does it mean that this line went down? What's happening there? Well, maybe if this is further and further and further away from school, then this would have to be closer to school. So Amadou must have turned around and moved closer to the school at this point right here. What about this point? What about this little flat piece right here? What does that mean in a graph? It means the rate of change is 0. If it's flat, there's no slope at all. No sled's going to go very far on that flat area. It means Amadou stopped. Amadou stopped moving away from the school altogether. All right, so Amadou must have stopped. Amadou wasn't moving further or getting any closer to the school. They stopped for a little while. Maybe Jolene and Amadou met up. Maybe Amadou slowed down and stopped, wait for Jolene to catch up. All right, so our first question. How many seconds long was Amadou's and Jolene's ride? Can you look right there and tell me how many seconds this graph, how many seconds was this graph going on? Pardon me. All right, well, I'm not going to say it, but I'll say the graph starts at time 0, and we go 4 seconds, 8 seconds, 12 seconds, 16 seconds, 20 seconds, 24 seconds, 28 seconds, and this is where the ride stops. Right here is where the graph stops. So what would that be right there? I'm going to let you try to figure that out, all right? I think we can do that. Remember what I said, right? Between 20 to 24, right? The number between 20 and 24 would be 22. So, each one of these would be 2. So 2 more than 28. 2 more than 28. That's right there. All right. How far apart were Jolene and Amadou at the beginning of their ride? How far apart were they at the beginning of their ride? So take a look. How far apart were they? Maybe you want to pause. All right, you unpaused me, hopefully, maybe. All right, how far? Well, Jolene's distance from the school was 0. She was at the school. Amadou's distance at the start was 40 yards away. So the distance that they started, a 40-yard difference. A 40-yard difference. If you think about that, a football field, 40 yards distance. So how far apart were they at the beginning? Well, 40 minus 0 is 40. So 40 yards away at the beginning of their ride. Maybe you want to pause me here. Okay, now I'm unpaused. List all of the times when Amadou and Jolene are the same distance away from their school. Okay, so where are they the same? They're going to be the same wherever those lines cross. And let me give you the coordinates of the harder one. There's 2 hard ones. Let me give you the coordinates of one of the harder ones. All right. I see 3 crossings. I see 4 crossings now. Do you see? I think you might see the first 3. This is the 4th one. All right. 1, 2, 3, 4. 4 crossings mean they're the same distance from the school at 4 different times. Let me talk about this one right here. I need a coordinate point for the time. Oh, actually, all I need is the time, right? So actually, I see that they're right there. They're about they cross right here. which is a little bit kind of funny. But okay, so this would be 22. So I would call this crossing to be 21.7, 21.8, something like that, right? If you gave me 21 or 22, I would take it. I would take it. So at least one of those times was 22 seconds, right? Or we could say, or more accurately, I might take it. I try to estimate 21.7, something like that, seconds. All right? You give me the other three there using what you just learned. Give me the other three. Probably pause me now because I want to talk about this number 4 here. Number 4. Describe Amadou's bike ride between 12 and 24 seconds. Describe the bike ride between 12 and 24 seconds. All right, there's the 12 seconds. There's the 24 seconds. So I need to describe the bike ride between here and there. Okay, here's how I'm going to describe. Jolene is bicycling steadily away from the school. Jolene is bicycling steadily away from the school. While Amadou is traveling faster away from the school and then must turn around and come back towards the school for a little while. So Amadou is traveling faster away from the school, and then Amadou, at 18 seconds, Amadou turns around and travels back towards the school for a period of time. And that's how I would describe that. Put that description into words. You probably need 2 sentences here. And the last question is, who travels the fastest over the whole 30 seconds? Who travels the fastest over the whole 30 seconds? Explain how you know. Okay. In order to, I hope I can I edit this? I don't know if I can edit this. Let me try. Do Control C, new drawing. Here I go. Post the drawing in there. Okay. Now I can draw on top of it. Let me give you Jolene's average rate of change. This is where she started. This is where she ended. All right. This is where she started. This is where she ended. So her average rate of change is going to be a straight line from when she started to when she ended. Right there. That line right there. I'll make it red. And I'll make it a little thicker. That's her average rate of change. That is Jolene's average rate of change. Let me do Amadou now. This is where Amadou started. This is where Amadou ended. This is where Amadou started. This is where Amadou ended. All right, I got to draw a line. You can imagine this in your mind. All right. There's Amadou's line. Let me give it a different color. Amadou's going to be green. All right. Oops, I don't want that. All right. So the question is, whose rate of change is faster? That's the question. And to answer that question, we look at these two lines, the red one and the green one. We say, which one of these lines is steeper? If you had a sled and were sledding down one of these 2 hills, which hill would you go faster on? All right, and so you would pick which one is steeper, which one you'd go faster on, and you would say something like, Amadou's or Jolene's average rate of change is faster because they have a steeper slope from beginning to end, and therefore the rate of change was faster. Therefore, their average rate of change would be faster. All right. And I do not want to save and close, or maybe I do want to save and close. All right. And then I'm going to undo what I just did. There we go. I undid what I just did. There I am. And that's it. That's the whole assignment. All right. That's what we're doing today. Okay. We're going to keep working on graphs and reading graphs and interpreting graphs and getting good with graphs. All right. This is Mr. Soul. I will see you in class.